Hi everyone. In this video, I'm going to explain about Bellman Ford algorithm. So before that, we discussed many of the graph related problems. So like Prim's and Kruskal. See, in the Kruskal algorithm, what we discussed the graph in which all the weights are positive. So again, we in the Prim's algorithm too, we discussed graph related problem. There also we used all our what positive weights. In Floyd algorithm also we use weighted graph, in which there also we used all our positive edges only. And in Dijkstra's algorithm also we used positive weights only. That means in general, in most of the graph related problems, in generally we have taken positive edges, but these edges may be positive or negative. Suppose if the edges are positive, then our Dijkstra's algorithm will find the shortest distance from the single source to all other problems. This is what we discussed in my previous video. That means in Dijkstra's algorithm, this Dijkstra's algorithm finds the shortest distance from the given source vertex to all other remaining vertices. Okay, to all other remaining vertices correctly if all the edges are positive. But if any edges is having negative edge, so then this Dijkstra's algorithm fails to find the shortest distance. Okay. So that means if the edges are negative, then it is not possible to use Dijkstra's algorithm. So if we want to find the shortest distance from the source vertex to all other vertices, if the edges are negative, then we go for algorithm what? Bellman Ford algorithm. So Bellman Ford algorithm is exactly same as Dijkstra's. Both are used to find out the shortest distance from the source vertex to all other remaining vertices. Okay, but Dijkstra's works only for positive edges, whereas our Bellman Ford algorithm used to find the shortest distance from the source vertex to all other vertices, even though edges are negative. So I can say this Bellman Ford algorithm is used to find the shortest path, shortest distance from the source to all the vertices for the general weights. That means in general, weights may be what? May be positive or negative. So for both, this Bellman Ford algorithm works fine. But the second role also it plays. That means this Bellman Ford, first it will find what? Shortest path from the single source to all other vertices, even though edges are positive or maybe negative. This is the first thing what it will find out. Second thing what it will find out, if there is any what? If there is any negative cycle, if there is any negative cycle present in the graph, that also it detects. Okay, so that also, which one? Bellman Ford algorithm detects. If the graph is having negative cycle, then it is not at all possible to find the shortest distance by using any of the algorithms. So this Bellman Ford algorithm finds the shortest distance if it is having negative edge also. But if it is having negative cycle, then it is not possible to find. So it will detect the negative cycle presence and says it is not possible to find the shortest distance. That is the role of this Bellman Ford algorithm. Let us see what do you mean by negative cycle. Let us the simple graph. This is the graph among three vertices, 1, 2, 3, and these are the edges, one positive, but this edge is having weight of -2, negative. Now you see into the graph and tell me what is the shortest distance from 1 to 3. So from 1 to 3, what is the shortest distance? So now 1 to 3, so at the first look we can say what? 2 direct, yes, 1 to 2, 2 to 3. So that means if I move from 1 to 2 and 2 to 3, so then distance is what? 2. Yes, all of you agree? Yes, but it is not right. So now here what we did, we moved directly from 1 to 2 and then 2 to 3. But instead of moving directly from 2 to 3, now you make this way. That means you move first 1 to 2, then again come back to 1 again and then again 2. That means, so first I move from 1 to 2 and again I moved from 2 to 1, again 1 to 2, then 3. Now if we like this, that means for this 1 plus minus 2 minus 1, 0, then plus 1. That means now the shortest distance is what? 1. That this is correct? No, this is still not right. Why? Because now I repeated this one. Now repeat one more time. That means now 1 to 2 to 1. One time again come back. Again you come back. Then you move to 3. So now this is see 1 to 2 is what? 1. 1 to 2 is 1. Then 2 to 1 minus 1, 0. Okay, then minus 2, minus 1, then plus 1, 0. That means now the shorter distance is 0. Now repeat one more time. So 1, 2, 2, 2, 1, 2, 2, 2, 1, 2, 1, 2, again 2, 2 to 1, again 2 to 1, 3. Now your short distance minus 1. So that means I repeated once, right? It is by 1. Repeat one more time, 0. Repeat one more time, minus 1. So if you repeat one more time, I'll get minus 2. If you repeat one more time, I'll get minus 3. Repeat one more time, minus 4. Like that, never ending, it goes minus infinity. That means there is no shortest path if the graph is having negative cycle. Now this is due to the negative cycle. So what do you mean by this negative cycle? See 1 to 2. See this is the cycle, right? This is cycle, closed path. Okay, the total weight of the cycle is what? Minus 2 plus 1 is what? Minus 1. So the total weight of this cycle is what? Minus 1. So that is what the negative cycle. If the negative cycle is there, see the shortest distance we never find. See first 2 minimum, then 1. Among these two, this is minimum. Then this 0 is minimum, minus 1 is minimum, minus 2. So it never ending, it goes on. So this is the problem. Now let us take, this is a positive weight. Okay, suppose, assume now, this is, instead of 1, I'm taking 4. Okay. So now, if you repeat now, 1 to 2 to 3 is what? Now shorter distance is 5. Now, if you now repeat this 1 to 2, 4. Then this one plus minus plus 2. So again, this is 6, 7. That means this is 7. If you move like this is 9. This if you move 11. Let it keep increasing by 2 every time. But among this which is minimum, I can surely say this is minimum. But here I cannot say which is minimum. It is never ending. It keeps going. But here I can say which is minimum. So see, here even though negative edge is there, so the total weight of the cycle is positive. So here we can find the shorter distance. But if the total weight of this is what? Negative, so then it is not possible. So this is the problem of negative cycle. So if our graph is having negative cycle, then our Bellman Ford algorithm detects that negative cycle and says it is not possible to find a shorter distance. If it is not having positive negative cycle, even the negative edge, it will find a shorter distance. Okay, that is the beauty of this Bellman Ford algorithm. Okay, so now let us take on simple problem, and for that now I will go and write the algorithm. Let us take this simple graph. This graph is having 2 cycles. See, this is 1 cycle and the total weight of the cycle is 3 plus 1, 4, 4 minus 2, 2. The total weight of the cycle is plus 2, not a problem. But now one more cycle we are having, which is that, see, this is the outer, this one, square type. Okay, this cycle. So what is the total weight of the cycle? 3 plus 2, 5. 5 minus 4, 1. 1 minus 2, minus 1. The total weight of the cycle is minus 1. So it is not possible to find the shortest distance because it keep decreasing like this. It keep decreasing the value, keep decreasing. So if it is keep decreasing, it is not possible to find the shortest distance because it is having the negative cycle. Now that we will look into the Bellman Ford algorithm. Now this Bellman Ford algorithm works in 3 stages. Okay. So in the first stage, Bellman Ford algorithm do initialization. Okay, that means it will initialize the shortest distance from the given source vertex to all other vertex. It will initialize, and it will also find whenever we are moving from one vertex to another vertex, it also finds from which vertex we are moving to which vertex. For example, assume in this taking example, I'm moving vertex 2 to 2 from where? From 1. And we are moving from vertex 2, vertex 3 from where? From 2. We are reaching vertex from where? 2. That means the predecessor we will call. So the predecessor of the vertex. That means predecessor of the vertex means from which vertex we are reaching which vertex. That also it will identify in the initialization. So in the relaxation stage, whatever the shortest distance it finds in the one round, the first round, so that it will try to reduce, because always we are looking for what? Shortest distance. So shortest means minimum. So that means always we find to reduce the shortest distance. So that will be done for all the edges through relaxation. Okay, the third stage, after doing relaxation for all the edges, n minus 1 number of times. See, this relaxation have to do what? N minus 1 number of times. What is n? Number of nodes in the given graph. How many number of nodes are there? 4. So 4 minus 1, 3. So 3 times I have to do relaxation. After doing the relaxation, in the relaxation, what we are doing? We are trying to reduce the whatever the distance we find in the previous one. Okay, so after relaxation, then I'm checking whether negative cycle is present or not. If negative cycle is present, I will say false. That means whatever the shortest distance we found during the relaxation, it is false. If it negative cycle present, if it is not present, then I will say whatever the short distance we found, that is true. This is what? If no negative cycle. This is what? If negative cycle present. Okay, so this is what this will do. Now let us see one by one. So let us see how it will do initialization. So initialization, what I will do? So I will take one array called D. So that means it indicates shortest distance. Okay, distance from what? From the source vertex. Okay, source vertex. So in this example, again I'm taking A as a source vertex. So in general, what I will do in the dijkstra's algorithm, we take V. Now I'll take source vertex. Yes, source vertex X. Okay, I will take A, you can take whichever. So now, so this is A, this is B, C, D. So, but we usually take what? Index as a number 1, 2, 3, 4. But this is the nodes A, B, C, D for that. Okay. So now initially what I will do, all these are, I will make it as what? Infinity, initialize. And now I told we are taking one more, that is what? Predecessor. That means we are telling we are reaching which node from which other node. Okay, A, B, C, D. So that means I am reaching A from which node? C. There is no possibility, other possibility. A I need to reach what? From C only. Okay, so but initially what I will do? Initially will say everything what? Null. This is what I will do initial. Okay, so but now once after deciding the source vertex, what is the shortest distance from source vertex to itself? That we know 0. So that means what I will do, so distance to the shortest vertex, which is the shortest source vertex A. So distance from source vertex yes to itself, I will make it as 0. This is what the initially will do. For this now I will write the program, that is algorithm. See, I took the name initialize, this is the algorithm name. Okay, parameter to be passed is source vertex, which is source vertex, and the cost adjacency matrix for this given graph. Okay, so now what is source vertex we have taken? Source vertex we have taken as what? A. Okay, now what we did here, initialize made everything as infinity, and for all the vertices. So what I will write, for each vertex, what? Small v, because all the vertices A, B, C, D, all I did. So for each vertex v belongs to what? Belongs to belongs to our graph. What we need to do? So I did what? I took distance 1. So the distance for each vertex, what we did? We did infinity. We stored infinity. Okay. So next what we did? Pi of that what? V. For that one we did null. This is what we did, right? So that's it. We did end for. And finally, what I did, I made, after choosing source vertex, for the source vertex, I made 0. So I will write d of s is equal to 0. This is what I did, this one. Okay. So by this, this is the thing what I did here. Okay. This is done. Initialize. This is one part. See, after initialization, what is the second stage? Second stage was relaxation. Okay, this relaxation we need to do for what? All the edges n minus 1 number of times. Okay, so initialization was stage 1. Now stage 2, relaxation. During relaxation, what I am doing? For each edge, okay, for each edge, we are trying to reduce the shorter distance that we found in the previous edge. This shorter distance I need to reduce. Okay, reduce. So that I will do in relaxation for all the edges n minus 1 times. Okay, so now for that I will write the code first. See, this is the Dijkstra algorithm, what we discussed. In the Dijkstra's algorithm, what is the equation we use? This is the thing what we used, right? So same thing we are using, because see, both the Dijkstra's and Bellman Ford algorithm is same. Dijkstra's algorithm works only for positive, but Bellman Ford algorithm works for both positive and negative. I'm using the same thing. Here also I used U. Instead of dist, I used what? Instead of dist, I used what? Now here D. Instead of dist, I used D. For distance, here I used D. And one more thing. So here I used, in the Dijkstra's algorithm, we used U comma W. That is the edge. That is the edge. U comma W. But here I'm using the word V comma W. That's it. Okay. U comma V. That is the only difference. Okay. So now in the relaxation stage, we need to find for all the water, for all the edges. So I'm taking each edge as U comma V. U comma V I'm taking. Okay. So here U indicates from which vertex and V indicates, okay, so for each edge, that is U comma V. So where U indicates from which vertex and V indicates to which vertex. That means we are moving from which vertex to which vertex. This is from, this is V. 2. So we need to do the relaxation for all the edges n minus 1 times. Okay. So I will write this one on the algorithm. So name I'm taking as relax. So for each edge, so from which edge to which edge, and I need cost adjacency matrix for the given graph. These are the parameters that to be passed. Okay. So now what I have to do? So now I simply am checking what? If distance of V to which vertex I want to find out, if that is greater than distance of from which vertex I'm coming from plus cost of that U comma V. If this is true, then I'm assigned this is greater than this one. This is the previous distance, this is a new distance. If the new distance is lesser, if the previous distance is greater, we are assigning the same thing as the new one. That means I'm retaining the lowest one. So whichever is lower, that I'm taking. So here if this is greater, this is lesser, then it's lesser one I'm assigning to the distance. So, and then again, so we need to find out what predecessor also. I'm using predecessor also. That's it for this relaxation. Okay, relaxation algorithm. That's it. Okay, this is same as what? See, if you observe Dijkstra's algorithm, see in the Dijkstra's algorithm also we use the same formula. See, you can see same formula you can use. We used. Okay, see here, if distance of W. This is there U comma W, here U comma V, that's it. So W are replaced by what? V, that's it. Other than that, everything is same. See, same. If you observe here, W is replaced by V. Same U, cost of U comma W, U comma V, that's it. Okay, everything is same. Okay, so now we will This is the relaxation stage. Okay. So now let us see how this relaxation is used to reduce the value whatever we initialize this one. Okay. This is initially what? This is initially the values of the shorter distance and the predecessor. Okay. So now I will write the third stage. Third stage is what? Checking for the negative cycle. Checking for the negative cycle. That is our algorithm, which is that algorithm, Bellman Ford algorithm. See, in the state Bellman Ford, the parameter to be passed is source vertex and the cost adjacency matters for the given graph. First thing what it will do, it will call the initialization state. So whatever we did in the previous initialization, okay, this function is called by our Bellman Ford algorithm. It will call this one, so it will be get done. So okay, this will be done. These two things get done by initial. It will call. So then what it will do? I told it will do this relaxation, right? This will do this relaxation. So when it is doing this relaxation, so here it will work for only one. But this relaxation is done for what? For all the edges. For all the edges n minus 1 times. So I will write for I is equal to 1 to what? N minus 1. Because we need to, I told this one we need to make n minus 1 times. So I is equal to from 1 to n minus 1, what you have to do. So then we need to do relaxation for what? Each edge, right? So right, for each edge u comma v that belongs to set of edges of the graph, what you have to do? Now you call relax algorithm by passing this from which vertex to which vertex and the what? Cost adjacency matrix. You pause this one. That's it. End for. Now this is the second stage. This is the stage 1 initialization, stage 2 relaxation. After this, now I need to check for each edge. I need to check again. For each edge, I need to check whether it is still decreasing or not. Because see, if it is keep decreasing the value, if they keep decreasing the value, as we did the law, so initially. So if it is keep decreasing still, it means it is having negative cycle. So that I need to check that one. Okay. For that, what I will do? For again each edge in general u comma v belongs to our set of edges. Okay, what we need to do? So we need to do what? We need to check if still the distance of v, same thing, whatever we used here in the relaxation, same condition, if is greater than distance of u plus cost of u comma v. But here if it is still decreasing, that means still it is greater, this is new one is lesser, then it keep decreasing. Decreasing means what? It is having negative cycle. If the negative cycle, what we need to return? False. So we will say it is false. So return false. End if end for. So after checking for all the edges also, this condition is not true means, so comes out of the for loop and then return true. That means whatever the shortest distance we find out in this relaxation, that is true. That means it is not having negative cycle. So this is the indication and thus is the end of the algorithm. So now this is the complete algorithm. Okay, so hope you people understood. Okay, let us now trace this algorithm. Let us trace this algorithm. See, algorithm starts from this Bellman Ford algorithm. First step, it will call the initialization function, and initialization function will find out what? See, the distance matrix, it will, so distance array, it will find out for the given graph, that is for A, B, C, D. So 0, infinity, infinity, infinity. This is what we got. This is index 1, 2, 3, 4. And predecessor we found initially, that is null, 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 null. for this vertices. This is what initially what we got from the initialization. This is what already we did. Okay, so now this statement is over. Now I'm to do what? Relaxation. This stage, whatever written in the black color, this is what relaxation I'm doing. Okay, so for that, now first I is equal to 1. I is equal to 1. N is what? Here, what is the graph you have taken? So this is the graph you have taken. This is the graph you have taken. 4 number of vertices. So 4 minus 1, 3. 1 is less than or equal to 3. True comes inside for each edge. Now first edge. What is the first edge? So let us take first edge. What? A to B. So for A to 1, edge A to B, A comma B. So here this is my U, and this is my V. Now again the same formula. What is that formula or condition we used? Okay, so this is distance of V. Distance of V means what? In place of V, what is there? B. Distance of B greater than distance of U, that is distance of A, plus cost of what? A to B. Okay, so now distance of B. Now check distance of B. Distance of B is what? Infinity. Infinity greater than distance of A is 0, plus cost of A to B. Cost of A to B is what? A to B is 3. So infinity greater than 3. True. Relaxation. We are doing relaxation. Okay. Okay. So now if it is condition is true, comes inside. So same thing will assign to D of V. So that means V. V is what? In this case B. So D of B. D of B is what? So I'm writing here. See, same thing following. So 0. B is operated 3. 0, 3. Infinity. Okay. This is my what? Distance. Updated distance. Now, after that what we have to do? Pi of V is equal to U. So here U is A, V, pi of V, pi of B. Pi of B is equal to what? U, that is A. That means I am reaching B from A. So that's what? That means I am reaching B from A. This is what the meaning. Okay, remaining is what? Null only. Okay, this is what when I is equal to 1, that is A comma B, for A comma B. Okay, next I need to check for what? A to B is over. Next edge is what? A to B, this edge is over. Next it is B to D edge. Okay, next B to D. So here this is my U, this is V. Okay, so distance of D greater than distance of B plus cost of B comma D. Distance of D, check always the previous only check. Distance of D is what? Infinity greater than distance of B. Distance of B is what? 3 plus cost of B to D. Cost of B to D is what? B to D is 2. So infinity greater than 5. True comes inside. Same 5 assigned to what? Distance of D. So distance of D this is 3. Earlier we got distance of D got 5. So pi predecessor I got. See pi of what? According to pi of V is equal to U. V is D. Pi of D is equal to U, that is B. That means I am reaching D from B. That is I mean reaching D from B. So this is what? My predecessor. Null. Okay. So this is for second edge over. Next, this edge over. Now this for this edge. This edge is what? D to C. So next for D to C, here this is my U, this is my V. So now again, distance of C greater than distance of D plus cost of D comma C. So again, distance of C. So distance of C is what? Infinity. Infinity greater than distance of D. Distance of D is what? 5. plus cost of D to C. Cost of D to C is what? Minus 4. Infinity, 5 plus minus 4 is 1. Infinity greater than 1, true. Come inside, same distance we are assigned to distance of V. V, C, distance of C. So that means now I got distance of C, I am updating by 1. So 1, remaining I am writing as it is. So pi of V is equal to U. Here U is what? D. V is what? C. C I am reaching from what? D. Okay, then remaining as it is I am writing. So this is my new one. Now this edge is over. Now for this edge, let us take this edge. C to A. C to A. Okay. For C to A, this is my U, this is my V. So distance of A greater than distance of C plus cost of C comma A. Distance of A is what? 0. 0 greater than distance of C. Distance of C is what? 1. 1 plus cost of C to A. Cost of C to A is what? Minus 2. That is minus 1. 0 greater than minus 1. True. Come inside. That minus 1 I am assigned to distance of A. That means now distance matrix array is distance of A is minus 1. The remaining I am copying as it is 0. Minus 1, 3, 1, 5. So pi of V is equal to pi of C. That means phi of is C. The remaining A, D, B. From now onwards, it remains same. It won't change. Okay. From now onwards, I won't write predecessor. So I'll write update only the distance. Okay. So now this C to A over. Now the last edge what? B to C. So for that, okay. For that B to C, U comma V. So distance of V, V is C greater than distance of U, U is B plus cost of B to C. Distance of C is what? 1 greater than distance of B is what? 3 plus cost of B to C is what? Cost of B to C is 1. So 1 greater than 4 false. That means it condition, see this in the relaxation. In the relaxation condition becomes what? False. The condition false. It doesn't enter the if block, comes out. So that means, so we are not updating this one. We are keeping the same as it is. That is minus 1, 3, 1, 5. A, B, C, D. So predecessor is remains same. Okay, this is the final distance matrix, distance array when I is equal to what? 1. Similarly, now we need to do for what? I is equal to 2. Okay, so now I will do for I is equal to 2. I is equal to 2. Now the first stage what? Will come by 1. Okay, A to B. Okay, I'm writing directly. Okay, distance of B. Distance of B greater than distance of A plus cost of A comma B. Okay, so distance of B is what? 3 greater than distance of A is minus 1 plus cost of A to B is what? Cost of A to B is what? 3. Here, A to B is 3. So minus 1 plus 3, 2, 3 greater than 2, yes, right, this 2 I am updating. So that means my now new distance array is distance of B. Distance of B is 2. See, earlier 3, now it is reduced. Remaining will be as it is. Now the next stage after A, B, which is the next stage we took, B comma D. So for B comma D, so distance of D greater than distance of B plus cost of B comma D. So distance of D is what? 5. 5 greater than distance of B is what? 2. 2 plus B to D. B to D is 2. 2 plus 2, 4. 5 greater than 4, true. Come inside. So then I am updating now distance array. Distance of D is what? 4. Okay, because this is lesser I am taking 4. So that means 5 is reduced to 4. See, 5 is reduced by 1, 4. Okay, remaining I'm writing as it is. Okay, next, after B, D, next stage is what this is D comma C. So I'm taking D comma C. This is my U, this is my V. So distance of C greater than distance of D plus cost of D comma C. Distance of C is what? 1 greater than distance of D is what? 4 plus cost of D to C is what? Cost of D to C is minus 4. So plus 4 minus 4, 0, 1 greater than 0 is 0 is minimum. So my new distance array is distance of C is what? 0. See, that means 1 is reduced to 0. See, if you observe, see, 3 reduced to 2, 1 reduced to 0, 5 reduced to 4. Just keep reducing. So if you observe here also, 3 reduced to 2, 0 reduced to minus 1. Okay, so now still only 3 edges. Okay, after D to C what? C to A we need to do now. C to A. See, here this is my V. So V is A now. Next edge. So distance of V greater than distance of U plus cost of U comma V. Distance of A is what? Minus 1 greater than distance of C is what? 0 plus cost of C to A. Cost of C to A. Cost of C to A is what? See, C to A is what? Minus 2. So this is minus 2. Minus 2, minus 1, minus 2. Which is greater? Minus 1 is greater. So this is minimum. So again I am updating my distance array. Distance of A becomes now what? Minus 2. Now remaining I will copy as it is 204. 204. See, minus 1 to minus 2 it reduces. Minus 2 it reduces. Okay. So now for the next stage, after C to A. After C to A, what is the edge? B to C. So for B to C, now this is my U, this is my V. So distance of C greater than distance of U plus cost of B to C. Okay. So distance of C is what? 0 greater than distance of B is 2 plus cost of B to C. Cost of B to C is what? 1. 0 greater than 3. False. We are not updating. I am retaining as it is. This is my updated distance array after what? I is equal to 2. So now finally I am doing for I is equal to 3. I is equal to 3 as usual. First edge A to B, A to B. So I am taking. So this is A to B. Okay. A to B. For A to B, here this is my U, this is V. So distance of B greater than distance of A plus cost of A comma B. Distance of B is what? 2. See, this is my A, this is B, C, D. So distance of B is 2 greater than distance of A is what? Minus 2 plus cost of A to B. Cost of A to B is what? 3. So minus 2 plus 3 minus 1. 2 is greater than minus 1. Yes, minus 1 is lesser. So I am updating my distance array. That is distance of B as what? Plus 1. Distance of B is plus 1. Earlier 2, now it is 1. So remaining value I am writing as it is. Now the next stage, this AB over, next stage is BD. So this is my new edge I am doing now. This is my U, this is V. So distance of D greater than distance of B plus cost of B comma D. Distance of D is how much? 4 greater than distance of B is 1 plus cost of B to D is what? 2. 4 greater than 3. Yes, 3 is lesser. So I am updating now my distance of D to 3. Remaining I am writing as it is. So next, BD over next D to C. So D comma C, this is my U, this is my V. D comma C greater than distance of D plus cost of D to C. Distance of C is what? 0 greater than distance of D is what? 3 plus cost of D to C. Cost of D2 is what? Minus 4. So 3 minus 4 minus 1. 0 is greater than minus 1. True. So my new distance array is distance of C is minus 1. So this is minus 1. Remaining I am writing as it is. See, it keep decreasing. See, 2 to 1, 4 to 3, 0 to minus 1. It is keep reducing. Okay. 2 to 1, 4 to 3, 0 to minus 1 reducing. Okay, next D to C is over. Next C to A. C to A, this is my U, this is my V. So distance of A greater than distance of C plus cost of C comma A. Distance of A is what? 2 minus 2 greater than distance of C minus 1 plus cost of C to A. Cost of C2 is minus 2. Minus 1 minus 2 minus 3. So minus 3 is lesser when compared to minus 2. So I'm applying updating my distance array. This is minus 3 remaining as it is. See, minus 2 to minus 3 is reducing. So last edge B to C. B to C, this is my U, this is my V. Distance of C greater than distance of B plus cost of B to C. So distance of C is what? Minus 1. Minus 1 greater than distance of B is what? 1. Plus cost of B to C is what? B to C is 1. 1, 2. Minus 1 greater than 2. False. I'm not updating. So this is my final distance array. Minus 3, 1, minus 1, 3, A, B, C, D. This is my what? Final. So I is equal to 3. So when I is equal to becomes 3, next I becomes 4. So 4 less than or equal to 3, false. So the condition, this becomes false, comes out of this for loop. Now it enters into the final stage 3. So now I'm checking for each edge. So now one more time we need to do this one. Now one more time finally for each edge. So I'm taking the first edge as usual. First edge what I'm taking? A, B. So A comma B, U comma V. So again distance of B, that's what we are doing here. If distance of V, same thing. Distance of B greater than distance of U plus cost of U comma V. Okay, so that is distance of B is what finally? Distance of B is what? 1 greater than distance of A is minus 3 plus cost of A to B is what? Cost of A to B, where is the diagram, graph? Cost of A to B is what? A to B is 3. So minus 3 plus 3 is 0. 1 greater than 0. Yes, 0 is minimum when compared to 1. So again updating what? Distance of B. Distance of B. So distance of B is first is 1. Now I'm retaining the main other value as it is. See, now still it is decreasing. Still it is decreasing. See, if this is the true, what I told you, what I have to return false, return false. That means whatever we find at this shorter distance, this false because it's still reducing. Okay, so that means why? Because in our given graph, so we have the negative cycle. This is the outer cycle, we have the negative. So total weight of this is 5, 1, minus 1. Okay, so there hence this Bellman Ford algorithm says whatever we have find out, so that is false. Okay, this is how Bellman Ford algorithm detects the negative cycle. Negative cycle. Now let us check for positive cycle. Now you have to take negative cycle. Now see, same graph I'm taking. See, I'm writing the same graph. Same graph. I'll try the same. See, this is also 3. Okay, this is also 2. This is also 1. This is also minus 2. But here I took minus 4. Now instead of that, now I will take minus 2. Now see, I'm in 2 cycles. So in this cycle, what is the total weight? 3 plus 1, 4. 4 minus 2, 2. Total weight is 2. So that is positive cycle. Now check this cycle. 3 plus 2, 5. 5 minus 2, 3. 3 minus 2, 1. So total cycle weight is 1. That is a positive cycle. For this, first initially, what is the distance matrix? So distance array. Okay. So initially what? Initially it will be 0, infinity, infinity. Initially 0, infinity, infinity. I'm not writing the predecessor, just I'm writing only this one. This is very important. So 0, infinity, infinity. So now what I will do, so let us take first I is equal to 1. Okay, so first I is equal to 1. So first edge A comma B. So this is what distance of B. Distance of B is what? Infinity. Infinity greater than. Infinity greater than what? So first I'll write 0, infinity, infinity, infinity. This is my distance array. Okay. So infinity. Infinity greater than what? Distance of A. Distance of A is 0 plus cost of A to B. A to B is 3. Infinity greater than 3. True. 3 is lesser. So distance of B I am updating. Distance of B 0, 3, infinity, infinity. Okay. This is my distance. Okay. Distance. Next edge. A to B is edge 4. Next B to D. So B to D. Distance of D. Distance of D is what? Infinity. See here only check. Distance of D. Distance of D is infinity. Greater than distance of B 3 plus cost of B to D. Cost of B to D is 2. Infinity greater than 5. True. So I am updating. So it becomes 0, 3, infinity, 5. Distance of D 5. So next edge. After B to D, we took D to C. D to C, that is distance of C. Distance of C is infinity greater than distance of D. Distance of D is 5 plus cost of D to C. Cost of D to C is what? Minus 2. 0 greater than 3. Yes, so 0, 3, 3, 5. This is the new distance array. So next D to C is over. Next C to A. So C to A, distance of A. Distance of A is 0 greater than distance of C. That is 3 plus distance of C to A is what? Minus 2. 0 greater than 1. 0 greater than 1 false. So I'm retaining the same thing. So next edge is B to C. So B to C. So distance of C is 3 greater than distance of B is 3 plus B to C is what? 1. 3 greater than 4 false. C 3, 3, 5. Okay, this is for what? I is equal to 1. This is over. So now I will take I is equal to what? 2. So same thing. Now again, first edge A comma B. So distance of B is 3 greater than distance of A 0 plus cost of A to B. Cost of A to B is 3. 3 greater than 3 false. So I am retaining. See, there is no change in the values. It is keep constant. Okay. Similarly, next stage what? After A to B, B to D. So B to D. Distance of D is 5 greater than distance of B 3 plus B to D is how much? 2. 5 greater than 5 false. So I'm not updating anything. I'm retaining as it is. Next, after B to D, it is D to C. Distance of C is 3 greater than distance of D is 5. D to C is how much? D to C is minus 2. So 5 plus minus 2, 3 greater than 3 false. I am retaining again. So D to C, after that C to A. So distance of A is 0 greater than distance of 3 plus C to A. C to A is how much? C to A is minus 2. 1, 0 greater than 1 false. I am retaining. So then the last edge B to C. Distance of C 3 greater than distance of B. Distance of B is what? 3 plus B to C is how much? B to C is 1. 3 greater than 4 false. Again I am retaining. This is done for what? I is equal to 2. Similarly now I have to do for what? I is equal to 3. So again A to B. Distance of B is, see, this is my latest distance. Distance of B is 3 greater than distance of A, 0, plus distance of A to B is 3, 3 greater than 3, false. So I am retaining same thing. So next A to B, after that B to D, distance of D. Distance of D is what? 5 greater than distance of B, 3, B to D is 2, 5 false. So I'm not updating, retaining as it is. So next D to C, distance of C is 3 greater than distance of D is what? 5 plus D to C is minus 2, false. Again I'm retaining. After that C comma A, distance of A is 0, distance of C is 3 plus C to A is minus 2. 0 greater than 1, false. I'm retaining the same thing. So next last edge B to C, distance of C is 3 greater than distance of B, 3 plus this is B to C is 1, 3 greater than 4, 4, false. So this is my final distance. Okay, so now I is equal to 3 over. Now I'll come to what? Relaxation is done. So I need to check the last one for each edge. See, for each edge I'll check again, there is no change. After checking, after it comes out, return true. That means whatever the shortest distance we found, that is the true. Fine. Okay, now check this with the graph. Okay, see, A to A is 0. That is fine. A to B, okay, distance from A to B. So this is A, B, C, D. Distance from B, A to B is what? 3. A to B, see, there is no other path. I can reach B only from A, so the distance from A to 3 is what? 3 only. See, this is what we got, right? So from the source, short distance from the source vertex A to A 0, A to B 3, A to C, you see 3, A to C. This, if you come like this, it is 4. If you come like this, it is 4. If you come like this, 3 plus 2, 5. 5 minus 2, 3. So that is what distance of 3C is 3. So this is also fine. So then distance of D. See, this D, I am having only one option. Only one option, I mean 5. Here to here 5. So that means whatever we find, that is fine. Correct, true. So this is how Bellman Ford algorithm finds the shortest distance from the source vertex to all other vertex, even though our graph is having a negative edge. But if it is having negative cycle, it returns false. Thank you. Thanks for watching. If you have any comments, please write it in the comments. Thank you.